Good afternoon, everyone. Welcome to our webinar today. We're excited to go over some interesting topics and hopefully we get to answer some of the questions in the industry. So without further ado, let me get started. We'll start with some guidelines and tips. Remove any distractions or hamsters that might distract you. Please, we recommend using the chat if you have any questions, anything to ask. Also, to get more engagement from everyone around, answer the poll questions. Everything is kind of anonymous, so please go and help us understand your interaction about the topics that we'll be covering, and then please take as many notes as you can so we can either get questions at the end further down, or also if you have any follow-up questions that we can connect with you further. All right, so quick round of introduction about our presenters today. I'll start with myself. My name is Antonious Messiha. I'm a sales engineer at Grantek, part of the Safety and Logistics Group. I have a certified machinery safety expert certification. And also today we are lucky to be accompanied with a safety specialist from UBSafe. UBSafe is a strategic partner in the safety world for Grantek. We've been collaborating together since 2017. So without further ado, I'll move it to Ian to give a more concise introduction about himself.
Sure. So like Tony says, just a Grantek partner. Actually, since before that, I think officially part of the program, but we've been working with Grantek since about 2010. And I think it even goes back into my days in Ontario, Grantek's early days that we've been connected. So a lot of history with Grantek. So yeah, thanks.
Awesome. Well, thanks, Ian, for the intro. With that, let's get started. A quick intro about who Grantek is. Grantek is a system integrator with 40 years plus of experience in the world of industry and different industries, with more than 200 people. In terms of the team, we offer different services in the integration world, from automation, safety, support, and so on. We have about 10 bricks and mortar offices and about another 4 satellite offices across North America, or in the world actually, because we have a few offices that are starting to be now in India and others coming up as well. So that means that we have full coverage across North America. So if you ever have any question or any request, we're here to help from east to west, and from north to south, basically. Yes, Grantek is an automation integrator at its core, but we have different core groups. And since we're talking about safety today, we have a dedicated core group that looks after safety and machine safeguarding. And that's who I represent today. And so if you have any questions or anything regarding safety or machine safeguarding, please don't hesitate to reach out to us. We'll be more than happy to support, as we have many experienced team members that will be able to answer all your questions in the different aspects regarding machine safety and machine safeguarding. All right, let's start with our first poll question for the day. What is your biggest lockout, tagout, or LOTO challenge? Here are the 4 main answers, so please feel free to interact and give us your answers. All right, give it a few more seconds. All right, great responses, everyone. Yes, most people, as expected, don't have a clear procedure in place. It becomes very complicated to also implement those procedures in place. So it's really a fair answer, and one of the main challenges that we really come across when we work with most of our clients. So thank you all for your feedback. All right, so our agenda for today is going over some of the fundamentals of hazardous energy control and lockout tagout. So just a brief understanding of that, of the fundamentals, and then what's new in the ANSI ASSP Z244.1 2024 revision, and then the alternative measures to traditional lockout tagout, and then how Grantek can help you, and then we'll leave some room for Q&A at the end. All right, so some on the fundamentals of energy control and lockout tagout. All of us in our facilities, or perhaps in different manufacturing facilities that you work for or you're contracted for, come different across different machines of different scales, sizes, and then you need to control those hazards. How are you able to control those hazards, and why you need to control them? So these are the basic fundamentals that we'll cover quickly today, to understand how we can look at the different consensus standards or general standards to help you look at lockout, tagout, and eventually the alternative measures. So essentially, from a brief understanding of what are the fundamentals is essentially isolating those hazards and making sure that we're isolating all the energies that we're going to face, and isolating those energies, meaning that there's zero energy achieved throughout throughout the process of the machine, to make sure no unexpected startup happen, or any release of stored energy could basically put any of the personnel in harm's way. So the isolation is not just for the electrical energy, but perhaps for all other energies that could be available or applicable for that particular machine or system. Could be mechanical, it could be fluid power, and other hazardous energy. So the standard in terms of the OSHA standards is what generally people look after or use for lockout tagout. Basically defines that any task that could pose such hazard, you have to lock it tagout. However, there's minor servicing exceptions underneath OSHA. So 29 CFR 1910-147, and then the subsections for it, allows for routine, repetitive, and integral tasks during normal production operations to be performed relying on alternative measures and not lockout tagout. Definitely, there's very minor allowances in that. That's based on the 29 CFR for the OSHA standard. However, in general, people are looking, to see how they can put a proper procedure to achieve isolation of those energy, and that's what lockout tagout is all about: is having the right set of procedures and the right set of procedures, as well as the training involved in order to get those fundamental controls in place. So if I can quickly advance to this slide here. So how can we have lockout tagout procedure in place? These are the four main points, but I want to spend more time on the written procedures. Written procedures should have at least the following 8 aspects: preparation, shutdown, isolation, locking out and tagging out, energy dissipation, verification, service and maintenance, and restoration. These are the kind of general, the framework that we have to have within the lockout tagout procedure overview, and that will result in a successful implementation of lockout tagout. A regulatory framework would also to include not just the procedure, but also ensuring that your employees, your contractor and subcontractor that are in the facility have the proper training to conduct those procedures, and then definitely conducting periodic inspections on lockout tagout equipment that are being used, and definitely using best practice or standard acceptable lockout devices, whether the lockouts, the locks themselves, the tags, and so on. So having those fundamentals in place, and then ensuring that you have a regulatory framework and a very detailed procedure will help you implement the lockout tagout program in your facility and all those machines um, as needed. Uh, but then we can also look later at the other complications that people will look at or come across usually, which is it causes production delays because lockout tagout could take time until you implement. Or if the machine is very complex, then that means you have a long set of procedures that you have to follow until you get the machine to be fully isolated and you have achieved all your zero energy until you get your task to be done. So another set of delays. And that also, because of the complexity of the machine, you might have multiple sources of energy that you have to isolate. And so just as we spoke in the earlier slide, it's not just the electrical that we're concerned with, it's the other sources, energy sources that could be available as well. And as I said, mechanical, uh, hydraulics or pneumatic and so on. And then ensuring that all your employees, so you might have a new set of employees, so you need to get another set of trainings in place, or perhaps you need to have your new contractors that are coming through your facility day in and day out to ensure that they have the proper training consistently. So that also adds up to the time of implementing the proper lockout tagout system. So these are definitely the common challenges, and that's how we're going to look at the in the next set of slides, how we can adapt the new standard like the ANSI ASSP Z244.1 in helping us kind of mitigate some of those challenges with using those standards to make sure that we implement lockout tagout when it's necessary, and then if we need to rely on the alternative measures, how it can be done and how it can be documented as well to ensure that it's done safely and the machine is isolated or stopped safely. All right, so if there's any questions, please feel free to put them here in the chat. Moving on to our next slide. So this would be our next poll question right here. How familiar are you with the previous version of ANSI ASSP Z244.1? Very somewhat limited, or what is ANSI ASSP Z244.1 anyways? Can I give some time for everyone to answer? All right, thank you everyone for interacting. So a lot of people have a limited understanding or familiarity of the standard. So that's great because that's what we're here for, to help you understand and navigate through that standard and how you can adapt it in your next set of machines or in your facilities. All right, so what's new in the ANSI ASSP Z244.1 revision of 2024? And I will leave that with you, Ian.
Very good. Thanks, Tony. Just needed to unmute myself here. So in the next few slides, we're going to talk about 244.1 and specifically a fair bit on alternative measures. We only have 45 minutes together, so we're not going to be talking about specific clauses, etc. I want to give you an overview of the concepts of where things are moving and how to apply this standard. There's a history of the 1910.147, the minor servicing exemption, and then the 244.1 standard in 2016, and the, let's call it the gap between those two and the pushback between those two. And the committee that has redone 244.1 for 2024 has attempted to clarify these things. I think the biggest change to really note is that historically, regulation in particular looked at what kind of activity are you doing? Are you doing a production activity? Or are you doing a maintenance activity? And they attempted to define some of these activities. Maintenance, of course, requires lockout. production activities require safeguarding, and it didn't really recognize the overlap of these two activities. So, you have to put a guard over power transmission components, and if you have to remove that guard, then you have to lock out. And it really looked at things in a very binary nature, but it didn't consider, as we've evolved into automation and as we've evolved into minor servicing and routine repetitive interference tasks with the machine, like clearing a jam is a great example, or clearing an obstruction to the normal flow of material, and the impact that has and how that gets handled through regulation. So in 244.1, and we're seeing this in other jurisdictions, that's aligning more towards what's happening in Europe, where historically it said you must lock out. And if you can't lock out and it's not practicable, then you start looking at alternative means and measures. And how that got applied, there's a lot of confusion in there. The way things are moving and what 244.1 attempts to do is to say, evaluate your tasks and hazards and choose the right level of isolation. And that's different. Instead of saying, lock out, and if you can't lock out, then X. It says, let's find the right isolation to the right level of tasks and apply that isolation. So different isolation methods are safer for different tasks. I think we can probably go to the next slide here. Well, just a second, actually, Tony, before you do that. And I just want to say that in the 244.1 standard in 2024, it's written from a user's perspective. It's quite understandable. It's very detailed in, take this step, then take this step, take this step. And how do you do each of those steps? How do you write a program around alternative control measures? And it's quite defined in each step. So it's really made, I think, for user understandability, and it's using very plain language. So a lot of documentation requirements. We're going to go into that on the next slide. Go ahead, Tony. Next slide, please. Okay, so I'm going to go through. We'll move. I'll actually go through it in the next slide. But I'm going to go through this framework of the alternative methods and basically what are the steps that you need to consider in applying that. We'll talk about the technologies. We're primarily talking about safety integrated systems here and functional safety systems. But there's also other alternative measures like freeze plugs and things that are more mechanical based, and they're all covered within the standard. You never get away with just applying one standard. So if you're looking at 244.1, you're also going to get pulled into, as you get into alternative control measures, you're going to get pulled into the 1119, and you'll get pulled into ISO 13849. 244.1 is a really good starting point and gives you a really good overview as to what direction you need to go to follow these what's called normative references within the standard. And then performance-based approaches, what we're really talking about here is, as we get into this, we're going to talk about risk assessment, and the performance level of our isolation needs to meet or exceed the level of risk faced. So when we're applying procedures and awareness means, is that equaling or below the level of risk faced? Okay. Next slide, please, Tony. And we have another poll. So please,
yes,
implemented or applied ANSI Z244.1, 2024, or I suppose 2016. Have you applied these in your workplace?
let's see.
Okay, great. So, and I just want to touch back on some of the other poll questions, like the first one on the biggest challenge with lockout tagout, overcomplicating the simplest tasks and requiring a lot of time. This is really going to speak towards this overlap of lockout and safeguarding known as alternative control measures. Okay, next slide, please, Tony.
Actually, just before I advance to the next slide, majority of people say they're not sure if they have implemented or applied the ANSI. So it's also kind of good that we're here today to help you understand how you can apply it better and adapt it better. So
hopefully once we talk about the documentation requirements there, you'll have some clarity on that.
Yes. All right, here you go.
Okay, so alternative measures compared to traditional lockout. So again, we really have three types of entries into a machine. We have an entry where we're going to go to a zero energy state, lockout, tagout. We have an entry that is production based where we are safeguarding and we may be getting to a zero energy state or we may be at an intermediate energy state. And then we have this overlap for minor servicing. So things like lubrication, clearing jams, cleaning, adjustments, etc. Okay. So when are they appropriate? Well, I kind of just touched on that. We're really talking about tasks where it is repetitive and routine and integral to the normal use or normal maintenance of the machine. So we're not talking about tasks where we're maybe cutting into an energy source, so or where I'm using tools. If I talk about a planer is a great example in the sawmill industry, there are different kinds of jams. There are minor jams, which are quick and routine and repetitive to clear that takes a very short period of time and doesn't require tools. And then there's jams where they need to go in with crowbars and chainsaws and things. This is a more serious jam where we need to consider lockout. So alternative measures should be appropriate for tasks that are short in duration and frequent in nature. Now, what are the requirements? How do we get started with this? There is a list within 244.1 in section 9.2 if you're interested. The first two things is your feasibility and justification analysis and your risk assessment. So 244.1 specifically says if there is not a risk assessment on the machine, you must lock out. So it's covering, if you don't have a risk assessment and you don't know what you've done or why you've done it, then they're trying to push you towards lockout. If you want to start performing these minor servicing tasks under your safety integrated system or functional safety, we have to start with risk assessment and we have to start with the justification. And I like that they use the word feasibility. So typically when we do these justifications, particularly in areas where there's legislative or regulatory approvals required, we have to focus on the safety needs and the safety reasons for it. But when we enter the word feasibility, we're also talking about the uptime and versus downtime, et cetera, and the production needs. So, because there's a lot of cost savings in this. It can be, again, if I talk about a planer system, utilizing the safety control system versus lockout cuts the per entry occurrence downtime by 50%. So these are significant numbers. However, in our justification, we do really need to focus on the safety needs of it. So how complicated is lockout? Is there is the complication of lockout driving people to not lock out? Is the time required for lockout increasing frustration levels, again, leading to circumvention of lockout or circumvention of the validation of lockout, usually the first step that falls apart? We want to also focus on the frequency that those energy isolating devices are being utilized. So disconnects, for example, how many cycles of a disconnect before it fails? What's the failure mode of a disconnect? It's an unmonitored device that likely fails to unsafe, where a stab stays in. So when we're doing routine repetitive tasks, is lockout the safest way to protect that person? Maybe not. If we're utilizing, I keep slamming disconnects, but if we're using an electrical disconnect multiple times per day, when that disconnect has failed, the operator might not face the hazard. Say 2 of the 3 stabs on a disconnect still open up and it stops the motor out there and the operator is able to go clear the jam. It appears that it's all okay. And then when they reset the disconnect, maybe everything's fine. It all starts back up. But when the maintenance person goes to use that disconnect now, depending on the verification method, usually it's just push to start for a lot of places. They won't realize that one of those stabs is in and that electrician is facing potentially hazardous energy, okay, because they're not at zero energy. So my point being, by utilizing a lockout for all minor servicing tasks, particularly frequent ones, we're actually creating an unsafe situation. So, and this is the premise of the standard, is figure out the safest and the best way to isolate for the task that's performed. Okay, so that justification needs to touch on all those points. From there, we move into risk assessment. In risk assessment, we're figuring out the tasks and the hazards that are faced, and then we're applying a risk reduction measure that meets or exceeds the level of risk faced. And depending on the method that you use, we like to follow one from the RIA called TR 15.306. This method is quite straightforward in how to meet the requirements of the standard. Other methods, there's no requirement as to which risk assessment method you need to follow. And there's several examples given within the standard. So you can even create your own using one of these other typical methods as your sort of minimum barrier as to minimum level that your risk assessment method needs to meet. So the key there is the tie between the risk levels and what's called the hierarchy of safeguarding controls or risk reduction measures. So what is the most effective to least effective way, and when do I need to apply that as a minimum? And that's really covered by the risk assessment model. Within that, usually within the risk assessment or the solution, we're going to look at industry best practices. Sorry, I'm reading from a list here that I'm looking left. We're going to look at industry best practices. We're probably going to be looking at applying functional safety. So when do I need to utilize safety devices? When do I need to use dual channel circuits? When do I need to monitor all those components? And what type of monitoring do I need to do? That's all part of functional safety. So that risk assessment model will help guide you into the application of functional safety into what level. There is a key point within the standard on exclusivity and individual control. So sometimes in our solutions, we're putting the machine into a safe state, but we're isolating everything before we enter, but we might be able to reapply certain hazardous energies, like maybe turn over a cylinder or something through manual control in what's called an enabling device in our safety circuit. Exclusivity of control would point out that the person operating that manual control is the only person that can operate it. It's not, we have to disable the controls from other stations. We have to forcibly disable automatic mode, etc. So all of these points are touched on within the standard. And then past the technical, it talks about, the tamper resistance of the isolation device that we're using, or the alternative control input element of our alternative measure. It talks about the program and procedures that need to be in place. When can you utilize your alternative measure? When do you need to lock out? And when are you just entering under production? This is all part of the procedural and training controls that need to be in place. And again, the standard really steps you through this one step at a time quite well in quite plain language, not your usual standard speak. And then there's a requirement for periodic check and test. When we apply functional safety, there are steps called engineering verification and system validation, where we inject faults into the system, prove the fail-safe nature of the system, and document all this. This document gets locked down and it becomes our change control. And within 244.1, it says that at least yearly, we need to open up these, particularly the validation document, and run through those validation checks again and make sure nothing has changed in the system. And there's a few key points within that. I'm not really going to go into the depth of verification validation, but it's all part of the process, both in applying functional safety and meeting 244.1. So it becomes part of your preventative maintenance routine to maintain and retest your safety system. Okay, I think I've gone on about that enough. We can probably move on to the next slide here. But on the right there, just before you switch, Tony, sorry, a lot of what we're talking about here is utilizing safety rated systems that meet a certain fail-safe performance level. Okay, so for example, a lot of the systems that we put out there are called performance level D, and we're talking about a failure rate of 1 × 10 to the -8 to 1 × 10 to the -9. Very, very low chance of failure. very low probability of failure would be the right term. And all of that actually needs to be documented. And it all ties back to risk assessment. Okay, on to the next slide, please.
Great explanation, Ian. Thank you. So moving on to the next, I believe, should be another poll question we have here. All right. So the next question is, how familiar are you with alternative methods? Very somewhat limited, no familiarity at all. We'll wait for everyone's response, please. All right, so we got some good answers right here, kind of split between somewhat and limited, which is, again, we're here to help you navigate through the understanding and help you understand the alternative methods that you need to kind of adapt and how to apply them to adapt the new set of standard like Z244. Sorry, Z422.1. All right, so moving on to the next slide here. Here's how Grantek can help. So how can we help you through a similar, like a webinar like this one, and then eventually into the project itself, how we can help and assist. So Ian mentioned that there's a need of set of documentation to adapt Z244.1, and that's definitely through risk assessment. But I'll take it one step before. Let's say you just want to work based on the OSHA standards and requirements of just strictly on the lockout tagout. Grantek can help you develop lockout tagout procedures or review and update your existing procedures if you have them in place, just to make sure that you're following the requirements fully. But then if you think that the procedure you have are a bit more complicating the process of putting your machine or isolating the energies of your machine, then again, understanding the implementation of the Z244.1, Grantek can help by providing the consultation services that we're capable of, by providing either safety consultation for safety audit, understand the different machines, the different risks of each of the machines that you have in the facility, then conduct a detailed risk assessment on those machines, and eventually we can start from one machine to the whole facility and develop a more robust safety program that can be adapted for existing machines and any machines that you will have in place in the future or in different facilities, and also provide the training solutions to understand how to navigate through the lockout tagout procedures, or how to understand the risk assessment and the validation documents if you're adapting alternative measures in the facility. And definitely we have 24/7 support, so we have our ongoing support to helping you navigate through your understanding of the standards, the risk assessment that we have helped you develop for your machines, and also to continuously support you with any procedures that you need to develop or update for your lockout tagout. Moving here, I actually want to look more at the different levels that we can help with through our services. Again, we have let's say 4 groups of services that we can provide at Grantek within the safety team: consultation, the engineering, installation, fabrication, as well as the commissioning and support. But how we can apply them, we can apply them from as simple as the machine level all the way it becomes kind of full standard on the corporate level that you get to apply from the one facility all across the other facilities that you're looking after, or your company's looking after, to make sure you have a more standardized system that you follow. So whether it's a system for lockout tagout procedures, or a system for adapting risk assessment to look at the implementation of alternative measures through Z244, for example. So again, Grantek is able to support you from the consultation side, as I said earlier, by providing a detailed risk assessment per machine to basically outline the different tasks and the hazard associated with each of the tasks, and and provide a score to each of those hazards and tasks. This way, you know exactly, do you need to go with lockout tagout procedures, or you can rely on alternative methods with these particular sets of hazards and tasks combined. Again, adapting it from machine level all the way to plant level and corporate level, and vice versa. If you want to just start with the program right away and then working your way through it to the machine level, the consultation service will help you. Safety consultation services will help you create those set of documents to basically come to a safe design, and then from there, engineering will work with you to create a safe design, and a remediation design plan to make sure that your machine gets to a safe level. And then the next step would be the fabrication installation of those um, designs that we have worked together with you to ensure your machine not just on document is safe, but also physically safe by implementing the right safety devices, safety rated devices, and it has the right safety architecture as well in place. This slide here is basically kind of summarizes what I've been explaining from the machine level to the corporate level, as well as vice versa from the corporate level to the machine level as well. All right, so I think we are coming towards the end of our slide here and presentation. Some of the key takeaways of today is hopefully we're able to provide you a better understanding of the new standard Z444.1 revision of 2024 and how it can be adapted in the industrial space. Clarity on the fundamentals of lockout tagout and its implementation, and then safety can be implemented in your machine level, but also can become a corporate standard. So that relying on kind of relaying the last few slides of how we can help you achieve safety levels from the machine all the way to the corporate and vice versa. Investing in safety in general is best practice because it will help you be best in class by reducing any safety incidents. Also making sure that you're kind of up to date with the standards and continuing to make sure you have a safe place overall. And hopefully from today, you're able to see that machine safeguarding is not really complicated, or lockout tagout is not complicated. Alternative methods are not complicated, as long as you have the right partner and right team that supports you to navigate through the different standards and putting together the right sets of documentation to get you to meet the right compliance and to be within compliance and adapting those standards. So without further ado, I think we'll come to our last slide here, which is questions. Please feel free to throw out some of the questions if you have any. Okay. All right, so we have one right here. Are we just trying to replace lockout tagout? What do you think, Ian?
Yeah, good question. No, it's the right isolation for the task and hazard combination faced. Okay, so lockout tagout is essential when we're performing maintenance activities that require a zero energy state. And kind of back to what I had stated before, lockout's essential for that, but lockout is the wrong choice when we're doing things routine, repetitive, and short in duration. Okay, even well put together lockout systems that are, localized disconnects or NCC stations that are right outside of the machine space. I've seen too much of the procedures falling apart when it's, and again, it's that verification step that falls apart first when somebody gets hurt, or failure of the device. So we're not trying to replace lockout, but we're trying to pick the right solution or the right isolation method for the task hazard combination performed. So I hope that answers the question.
No, exactly. And again, kind of the requirements are essential kind of guidelines that we follow, but we also look at the alternative measures that would make things simpler for the kind of the routine tasks, perhaps, but without deviating too much from the standards or the requirements. So thank you for clearing that out, Ian. Another question here we have: what are the first steps when considering alternative control measures? I think the first part of answering that question would be have the right documentations in place. So conduct a complete risk assessment that will help you have a better understanding of your tasks, the hazards involved with those tasks, and based on the risk score and the risk levels, is that something that can be mitigated by alternative measures like safety devices and safety control measures, or it cannot be kind of remediated to a lower risk level with these devices, and lockout tagout is the only means to ensure a full isolation. So I think that's my first quick answer is ensure having a proper risk assessment conducted to make sure that you're able to, any alternative measures that you're able to adapt, that set of documentation for the risk assessment, which is the risk assessment, helps you kind of outline those different measures that you need to adapt. Anything to add, Ian?
I think just to be aware, like don't rush through this process. Don't try. You have to do this methodically. You have to do your analysis and justification, and you have to do your risk assessment. And just standing back and looking at the machine and saying, okay, what do we do? We'll just throw it into manual mode. Well, no, specifically, that's not an alternative control measure. So do it methodically. You need to really understand what your people are doing and why, not just what the standard operating procedures say, but what they're needing to do on the machine and why. And you need to really understand the hazards that they're facing doing it. So you only get there with a team-based approach, and you get there methodically.
Perfect. Thank you, Ian. Let me see if we have any more questions. Yeah. Another one here. How do I know our lockout tagout procedures are correct? Good question. One thing is to make sure they have a good understanding of the machine and different energies of the machine. That would be like a step number 0, I guess. And based on that, are you covering all these different energy sources? Are you isolating them all correctly through that set of procedures you have? And again, if you're in doubt about the procedures and you want to have a more depth and methodological review, then working with the right partner will help you review those set of procedures to make sure that you're covering all the different aspects of isolation of those energies, and making sure they have those procedures really conducted in a methodical and a more organized approach to make sure that you're isolating everything correctly. So if you're not too sure about how correct they are, working with the right safety partner will help you navigate through your procedures and update them if necessary, or confirm if they're all correct, then you're good to go.
I'll just add to that, Tony, that
Sure.
The standard really steps you through lockout tagout very methodically and very well. So things like that there's a requirement to use a lockout procedure once a year, and to check that procedure and revalidate that procedure every 3 years. This is part of your program, right? So going through and really making sure you've got a good program around lockout, not just the procedures. And I'll use an example of a client that we're working with that, they've got a beautiful factory. It's 6 years old. All the machines and equipment are very well safeguarded, or appear to be. And, on everything, there's lockout placards, all their energy isolating devices are identified, and everything looks really good. It follows the examples given in 244.1. But at a quick glance on the procedures, their lockout method is to go to the MCC room that's about a 20-minute walk away to lock out a very simple hopper to be able to, open a hatch and clear jam within the hopper. And there's a localized disconnect there. And, just at a glance at the procedure, it's like, well, first off, nobody's following this procedure because it's going to take 20 minutes to go to the MCC room and back, and then how much longer just for applying lockout. Second thing is this localized disconnect, and everybody's shrugging their shoulders saying somebody put it in at some point. And I'm not trying to fault this organization. It's just, they put together a really good looking procedure, but the details in it are lacking. And it's a good client that's come to us and said, look, we realize this and we want to really go through the details. So we'll do an engineering analysis. Like lockout isn't just written between production and HR. There needs to be maintenance and engineering involved. You really need to look at, are those energy sources being isolated? And you need to evaluate those schematics. If we've got fluid power, is there trapped energy between valves and actuators? And ensuring that's all part of the procedure and how it's verified. Right? Verification methods are a big part of it. So I'm kind of rambling here, but good question. Thank you.
This is a great addition, actually, Ian, because he used like a real life kind of example. So hopefully that kind of resonates with everyone. I don't think we have any other questions. I don't see anything else. I believe this was our last question. Again, thank you everyone for your time. Thank you, Ian, for coming out today and helping us with this webinar. Hopefully we're able to help you out navigate the understanding of the Z244.1 and also better understand about the fundamentals of lockout tagout. And lastly, how we can help you here at Grantek with your safety needs, particularly into the lockout tagout procedures or setting up expectation with risk assessment to use for alternative measures if you're adapting Z244 in your facility. Again, this recording session will be sent out to everyone here in the attendance. So if there's any other questions, feel free to send it to info@grantek.com, and we'll be more than happy to help you and support you with all your safety needs. Have a wonderful day, everyone. Take care.